connected data, J is more powerful than ever. You want enhanced performance? Neo4j is unmatched in the market. Neo4j was already 1,000 times faster than relational databases, and with version 5, Neo4j widens the performance lead with new features like K-hop query optimization, graph pattern matching, and granular indexes. You want your data to scale? With 5, Neo4j has unbounded scalability. Autonomous clustering lets you scale out horizontally with less manual overhead and better use of computing resources. And when your datasets lie in multiple databases, Fabric instantly helps you create a composite graph of insights hidden in disparate silos. You want agility? Neo4j 5 has unparalleled operational agility. Neo4j fits your IT strategy, whether it's on-premise, cloud, hybrid, or multi-cloud. And with Neo4j Ops Manager and a continuous release support model, it's easier than ever to manage your database in the cloud. Neo4j 5 helps you achieve unbounded performance, scale, and agility. Find out more at neo4j.com. For over a decade, Neo4j has been helping the world make sense of data. Today, Neo4j, the leader in graph database and analytics technology, is unlocking new possibilities in generative AI. Together, Neo4j and large language models allow you to use a public, pre-trained LLM with your own data, subject to your privacy controls. Reduce hallucination through a powerful combination of deterministic facts and probabilistic conclusions. And enhance explainability and transparency through explicit knowledge representation for getting transparent reasoning and explainable AI. Neo4j's scalable and flexible technology seamlessly integrates with generative AI frameworks like LangChain, Vertex AI, OpenAI, and beyond, democratizing access to the world's information while setting a new standard for AI accuracy, transparency, and explainability. Unlock new possibilities in generative AI today at neo4j.com. There are many types of databases today. The tried and tested relational database, the new and popular document DB, and many others. And all of these have their strengths. But one place they all fall short is in handling complex connections between your data. Sure, any database may be able to return friend of a friend queries of 3 or 4 degrees, but what if you need 20 degrees and need it quickly? That's where Neo4j comes in. Unlike other databases, Neo4j Graph Database doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of deeply connected data are orders of magnitude faster. We get used to the limitations of the tools we work with. Neo4j blows those limits wide open, enabling queries never before imagined at speeds never thought possible. That's why Neo4j has become a key technology driving business-critical applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Learn more at neo4j.com. Are you interested in graph data science but don't know where to begin? The Neo4j Sandbox is the best way to get started and learn graph data science basics with interesting preloaded datasets like fraud detection, contact tracing, and Twitter trolls. It's easy to jump right in, follow our guides, and explore visualization with Bloom. There's no download required, and you can get up and running in less than a minute. Try it for free today. Graph databases have been the fastest growing database category for the past decade. The reason for this is simple. Graph databases are highly optimized to understand and work with the complex relationships between your data. Unlike other kinds of databases, a native graph database doesn't need to search for data connections at query time. Those relationships are already there, stored right in the database. Because of this, queries of large, complex, connected data are orders of magnitude faster. A graph database doesn't necessarily need to replace your current database. By adding graph capabilities to your current infrastructure, you can keep the technology you already have, but greatly improve it with the power to uncover rich data connections, reduce time to market, and run faster queries. Taking advantage of the connections that already exist in your data enables you to get ahead of the competition. Every business needs to leverage data relationships and leverage them faster and more efficiently. Graph databases deliver those capabilities. The speed and efficiency advantage of graph databases has driven new, real-time applications in fraud detection, customer 360, machine learning, and knowledge graphs, just to name a few. Because of this, graph databases have become a key technology creating competitive advantage for hundreds of Fortune 500 companies, government agencies, and NGOs. We asked 100 senior tech executives, CIOs, CTOs, and chief data officers what they need to bridge data silos, boost AI/ML projects, and open up new revenue streams. A massive 88% of them said the same thing: knowledge graphs. But why? Leaders know the value of data, keenly aware that it holds the answers to their most pressing business questions. They need insights to improve decision-making and enhance business performance. Enter knowledge graphs. A knowledge graph is a map of everything an organization knows about a given topic. Knowledge graphs help business leaders by functioning as a non-disruptive insight layer on top of their existing data landscape. Knowledge graphs drive intelligence into data to significantly enhance its value without changing any of the existing data infrastructure. Knowledge graphs enhance existing technologies by providing better data management, better predictions, and better innovation. Last but not least, knowledge graphs lend themselves to multiple use cases like fraud detection, digital twin, patient journey, bill of materials management, recommendations, and IT operations across many industries, including financial services, healthcare, life sciences, manufacturing, supply chain, and retail. The C-suite is waking up to the possibility of knowledge graphs. Shouldn't you?
Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining our this week's Neo4j live session on entity resolution and deduplication with Neo4j and GenAI. I'm super happy to be joined by Johannes Jolkkonen. Thank you very much for coming. Thank you for being here today, and welcome to the stream, Johannes.
Cheers, thank you. Great to be here.
And also happy to have my colleague and Graph GenAI expert Tomasz join us today as well. Hi, Tomasz. How's it going?
Hi. Happy to be here. Very exciting topic.
It is. It is.
It's very exciting. So I pinged in the chat a little bit earlier if people are struggling with duplicated entries in their databases, if this is something people are worried, and hopefully we can show them today a little way of using that issue. I'm sure that is a nightmare and a headache for many people if you have that problem. Before we dive in, I would say maybe we spend a few words on who we are and what we do. Obviously, I don't have to say who I am, but maybe Johannes, particularly you, maybe if you could say a few words.
Yeah.
If you have not listened to the Graph Stuff FM podcast this month, if you did, then this is probably a little repetition, but still, if you if you mind
Yeah.
introducing
No,
yourself.
I'll keep it brief.
Yeah.
I'm Johannes. I'm working as an independent consultant, background in data engineering and data architecture. And now, as of last year, I shifted my focus pretty heavily to just LLM and RAG applications with an enthusiasm for graphs in particular. Although there are still some like difficult technical challenges there compared to doing something simpler like a vector store, which granted also sometimes is the right choice when you just need something when you don't need such relationality. But if you do, then I think on the other side of these technical challenges, there's a lot of potential upside in using graphs. So that's also something I'm pretty enthusiastic about and trying to figure out how to make work.
Cool. And you are super active on YouTube, so you share lots of interesting content there. So if you are interested in watching more from Johannes afterwards, his channel is obviously in the video description, but also I'll post it in the chat just right now, so you can check that out. Give him a follow. There is great content on databases, RAG, as you said, LLMs, knowledge graphs. So really cool stuff.
Yeah, it's rather flattering to say I'm very active on YouTube. That's still something I'm working on, the regularity of creating videos. But yes, it is definitely something I also enjoy doing a lot.
Yeah, I mean, the ones that are there are good. And Tomasz, if you have, maybe scrolled around in any Neo4j blog in the past half a year or so, probably your name has come up in a couple of articles, couple of mentions, especially around the Neo4j LLM GenAI space. So, Tomasz, do you want to say a few words about yourself as well?
Yeah, so like similar to Johannes, in my previous life, I worked as like data engineering, and I also played around with graph algorithms a little bit. But for the past year or so, it's all about LLMs basically. I wake up, I talk to ChatGPT and try to convince it to work. And then I go to sleep, and then the next day I wake up and I do the same thing. And then when I'm bored, I try to use other LLMs that are not ChatGPT or like open source LLMs, and then I kind of appreciate OpenAI a little bit more. But yeah, for the past year, it's all about LLMs and how to combine them with. I mean, knowledge, because I also played around with vector retrieval as well, right? So it's kind of similar to see how you can combine the two. But nowadays we're I can spoil it, but like now the next blog post will be about constructing knowledge graphs with LLMs. So we don't have an entity resolution and the duplication technique there yet. So I look forward to learning something that we could apply in actual graph generation, because that's like a big problem. So yeah.
Cool. Yeah, this, like you just said, the big problem, the issue, entity resolution and deduplication, is that something you came across sometime recently, and that's why we picked this topic today, or was it obviously out of necessity to cover the topic and say, hey, we need to tackle this issue, we need to talk about it, or what was the motivation, I would say, behind today's presentation?
Yeah, no, it's definitely like I'm the one who suggested the topic, and it's like as soon as you start working with knowledge graphs, in particular with extracting knowledge graphs out of unstructured data, which is the the most maybe exciting thing that people are trying to make happen, and which wasn't possible before. Like entity resolution itself isn't a new problem, but what makes it now very relevant is the fact that now there's the possibility of extracting graphs out of non-graph data, but that comes with typically almost always this various degree of duplication issues, because of course when you're using various source materials, the entities can be extracted by a language model. They are quite good at that, but in different source materials, there can be alternative spellings, typos, different identifiers for different or the same entities, and hence although you can extract them, you can create the graph, it's not gonna be a finished product, let's say. So yeah, it's a problem that you run into very fast if you try and do something like this, and that's why I've been wanting to. Yeah, that's one of the main technical issues, I think, that I referred to earlier, and yeah, very very excited, but also hopeful to be exploring these different methods for solving it.
Anything to add to that, Tomasz?
Yeah, I mean, I'm just happy to learn, but basically, it seems like the whole academia, like used to, I don't know what they're doing nowadays. Nowadays, it's probably about LLMs only. But like there was a time when academia uh, did like entity disambiguations, entity linking, stuff like that. So I'm quite interested to see like what will you present, because I've seen a couple of examples on like entity disambiguation or like the duplication, but it's like there are like different categories of the duplication or the solutions, and like it's not like that one fits all of them. So I'm interested to see which process you will show, and which categories of the problems are they trying to solve.
Yeah, no, that's sadly so not something I'll demonstrate so much, but it's something I definitely am going to highlight, the fact that there's no like one algorithm you can run and spot all your duplicates and get rid of them, but rather it's going to look more like something like a ETL pipeline, or like a DAG like process of sequential steps that you run for your various node types. You might have like dozens of different duplication issues, and you might need a different kind of process or logic for all of them, and then it's just like a sequence of steps or sequence of sub processes that you need to run realistically. So yeah, for this demo, I'm gonna show, let's say, just one piece of that process, sadly, because it's difficult to demonstrate something, let's say, a full scope in a demo like this with dummy data or semi-dummy data. But hopefully it's going to be valuable either way.
I'm pretty sure it will be, and at least the first step will have been made, and that's already something. So I think that's great, and should be helpful. And then we can always continue the conversation later on, and maybe this sparks, maybe you continue this on your channel with another video, or maybe some other content will come up from this. So yeah, I think that's great. Cool. I think we could start. I think we're ready to dive in. As always, if you watch this live right now and you have any questions, any comments on the things we are presenting right now, then please don't be shy and use chat. I see a little conversation going on as well already. It's a little bit out of today's topic, I think. So we will try to see if we can answer some of these questions, but if it's something that fits the topic, then please obviously make sure to use the chat. If it's something you want to know in general, then we can always see if we have time for it. Otherwise, I invite you to join the community of Neo4j on either Discord or on our community forums, and there is it's a great way to ask questions and to interact with everybody in the wider Neo4j field. But yeah, I think we can kick it off, Johannes.
Very good. I'm just going to share my screen. Jump into a couple of slides first. Some of this we touched already in the intro chat, but yeah, we're gonna just talk briefly about what entity resolution actually is, what is the problem, why is it important, a quick overview of some of the methods that are available in Neo4j for solving the issue, and then finally the practical application. So entity resolution, it's determining whether or not two representations of an entity actually refer to the same entity. So again, as we mentioned before, if I was going to extract some entities from some data related to Amazon, for example, I might end up with two nodes, Amazon and separately Amazon Inc. But of course, these two should be considered the same entity so that we have consistency in our graph, and all the information related to Amazon is in the same region, in the same center of the graph. So that's the problem in a nutshell. As I also said, not a new problem, newly relevant because of the possible applications of extracting graphs with LLMs from unstructured or semi-structured data. And it's important because, yeah, if you have your duplications of your entities and your information scattered between those entities, it's going to definitely limit the quality of insights or quality of just the usability of your graph, quite obviously. Some methods, starting at the top, the dream case, wherever you can apply it. The simplest way is just business rules. In other words, if you can say that if we have two user nodes with the same phone number, then we are going to consider them the same user. If we have nodes of our offices in different locations, if they have the same address, we're going to consider them the same office. Beyond that, we have semantic similarity, which is going to be very familiar to anybody who's worked with RAG. So just vector embeddings of node properties, and then running semantic similarity on those vectors. So if we have a node with a name, company node with a name Tesla in the industry of autonomous vehicles, that's going to be similar as another one with the self-driving cars and Tesla Inc. And then the third one is more specific to graphs. And this is going to be structure-based similarity. So not just the properties of the nodes, but actually the relationships of the nodes. So if we have shared relationships or the same relationships between nodes, then we can also compute similarity based on that. So for our Amazon example, if there's a relationship has headquarters in Seattle or has a subsidiary AWS, was founded by Jeff Bezos, and if they share some of these relationships, then we can also leverage that in our similarity calculation.
Cool.
And that's the intro. Now the demo. So very first, we're just going to look at a very simple graph. And we're going to use this to show these methods that I mentioned, mainly structural similarity and semantic similarity in action. See how they work, how you can use them in Neo4j. So for this graph, we just have some doctors contributing to projects and working in a field or department of medicine. And the very first thing we want to do before we run any graph algorithms is create a graph projection. And for those who aren't familiar or are less familiar with Neo4j or the graph data science library, graph projection is like a saved temporary subsection of your graph. If you're familiar with relational databases, good analog is something like a database view. So you can save a view of your database or some section of your database. And that's useful because, first of all, you can specify which nodes and which relationships you want to include in the projection, so you can narrow the scope for which you run the algorithm. But also more generally, you need to define, even if you want to include all of your graph, you need to create the projection first, because you can only run the algorithms on these projections. So we're going to do that, including all our nodes and all our relationships. We can also specify the orientation of the relationships in our projection. So if it's undirected, then that means that the projection isn't going to carry any information about the directions of the relationships. It's just going to have the information that there is a link between these two nodes, for example. But if we change it to natural, then it's going to preserve the original directionality as well. But here we're just going to set it as undirected and create this projection. With the projection created, we can now run this quite simple node similarity algorithm, which you can find the details of in the Neo4j documentation. And this just computes a similarity based on the shared relationships and shared neighbors that the nodes have, and doesn't take into account anything else. So for our example, these are the scores we are getting. And just to put that in the context of the graph itself, the highest score we are getting for these two, Dr. Baker, Dr. Clark. And that's unsurprising because they do share two of these relationships. They both work in oncology. They both contribute to this same project. Now, the reason the similarity isn't perfectly one perfect similarity is that Dr. Baker also contributes to this other project, which isn't shared by Dr. Clark here. So that's just the basics of node similarity. And for the second one, which is the node embeddings, for that we're actually going to jump into VS Code. And the reason for that is that we are going to actually use OpenAI's ADA2 for the embeddings. And you can create embeddings in Neo4j natively as well. There are some embedding algorithms, namely what is it called? Fast RP. Yeah, fast random projection, which allows you to calculate embedding based on, you can include relationships, you can also include properties. So that is definitely an option in Neo4j native. But for a few reasons, one being that I'm just personally more comfortable with Python. But the second reason is also that just to demonstrate that you can actually also use any kind of embedding model that you want with Neo4j. And as you'll see in a moment, I think entity resolution is actually a case where it might be useful to have a fine-tuned embedding model. But just to show what we are doing here, we are just getting all the doctors in our graph here. And for each of those doctor nodes, we're going to get the text of the skills property, which all the doctors have. They have some set of skills. And this is what we're going to base our embeddings on. So we're going to embed those through the OpenAI endpoint. And then we're going to update each node with a new property embedding and set the value as the embedding. And now, if we reload our graph, in my notebook, I had a section for creating the graph, so now we have it double. But the point is that now we have this new property of embedding for each doctor. And whether you get that embedding from one of Neo4j's embedding options or something else, once you have that, then you can run the cosine similarity from the GDS library to get a similarity score based on the embedding property. And it's messed up a little because of the duplication I just created. But the main thing here is that for Dr. Clark and Dr. Baker that we looked at earlier, the cosine similarity of their skills is going to be exactly 1 because we have given them the exact same skills here. So we're going to have perfect similarity. And then it's just going to go down for the other ones. Now, generally, you'll see that all these scores are pretty high, although a lot of the doctors do actually have very different skills. And the reason for that is that we are using a generic embedding model, which is what Ada 2 from OpenAI is. And that means that although in the specific context of medicine, some skills might be very different, but for a generic embedding model, they're still all like medical terms. And as a baseline, they're going to get high similarity scores. And so that's what I mean when I say that a fine-tuned model might be useful for this kind of use case, because it is like we are quite sensitive to like subtleties in a certain type of similarity or difference in our values. So yeah, fine-tuned embedding model for this to get more precise similarity scores might be useful here. But that's just to demonstrate how these work, node similarity and cosine similarity in Neo4j. But now we're going to look at a slightly more realistic graph, which I have loaded here.
Maybe before we before we do that, there were a couple of points. Oopsie, let's do it like this. That came up in chat. So maybe we take a short break here. A good comment from Mark came in chat that is using Neo4j's vector search to find similar nodes and then subject those to rigorous pairwise logic. The ANN search does a fantastic job of reducing the number of pairs to compare, and he showed this in a session at Nodes 2023. I linked that one in the video description. So if you want to know more about that, then you can find that in the YouTube video description. Himanshu says, what I'm really interested in about is how graph structure is going to help in doing dedupe because other things can be done with other things.
Mm-hmm.
Yes, I guess that's something we're gonna show next, right? So that's like a look into the graph structure. So that's perfect. And then maybe quickly for Alex, I think it was answered, but just for everybody else, what kind of embeddings did you use? Text embeddings, node properties, or graph embeddings such as Node2Vec? I think you ended up using text embeddings, but
yeah, so there's a variety of options. Like you can use the node similarity algorithm for the relationships, and then you can separately do text embedding, or you can also do something like Node2Vec, which or fast RP, which allows you to create the embeddings based on both. What we are gonna look at in the next part is actually combining these two approaches that I just showed into some kind of like combined similarity score that we can then use for the deduping.
Cool.
But yeah, there's a lot of different options.
Yeah.
So it's just boils down to what suits you the best.
Personal preference. Yeah. That makes sense.
And what works the best.
What works the best? Yeah, of course. Yeah. Cool. All right. Yeah. If you continue with the questions, then I'll read them out as we go along. But I didn't want to interrupt your demo just while you were talking.
Yeah. No. Awesome. Feel free to interrupt me. I can steam through pretty fast.
Cool. Now I lost your screen, I think.
Oh yeah, I'm gonna redo it.
Yep.
All right.
Oh, there it is. Perfect.
So this time we are looking at a graph of Amazon and its various subsidiaries, as well as their services, some key people involved, etc. And it's been partially extracted from some Wikipedia articles about Amazon and AWS and Zappos mainly. But I will also say, in terms of transparency, I've also done quite a bit of post editing in order to make it more suitable for the demo. But for our purposes, what we are especially interested here is the fact that there are, in fact, two versions of Amazon here. We do have our Amazon and Amazon Inc., as I alluded to before. And we also have separately Amazon Web Services here and AWS here, sharing some of the edges and some of the properties. So we're gonna jump back into VS Code, and we're gonna try and see if we can apply the methods covered previously and try and detect these duplicates and then get rid of them. So again, the first step is going to be creating the graph projection, selecting all the nodes and some of the relationships that are relevant. And we're going to start by just running the node similarity on its own. And we're going to convert the results into a data frame. And indeed, because our duplicates here do share a lot of the edges, we do get high scores for them. Additionally, we can also see that we get some similarity for Amazon Fresh and Whole Foods, which is also not that surprising because they also here share some properties, both offering groceries being owned by Amazon. And but this again highlights the, I think, importance of not just relying on the structure itself, because that can be shared across nodes. But in fact, if they are different in other ways, in their properties, for example, and then that's going to be important to capture in our logic as well. So for the embeddings and the cosine similarity, the process is also going to look similar as in our previous dummy example, except that this time, instead of just taking one property, which was the skills property of the doctors, especially if we are working with a graph that's partially extracted from unstructured data, we might not always be sure what properties each node has. So for our embedding text string, we're going to join all the properties that a node has, regardless of any arbitrary amount of properties or their names that their node might have. And we join that into a text string. And then this text string is the one we embed, again, setting it as a new embedding attribute. And so we're going to run that. And then once the embeddings finish computing, then we're going to run the same cosine similarity function from GDS. And now we also get the scores for these nodes.
Can we zoom in a little bit into this one?
Oh yeah, please.
Yeah, cool. Thank you.
Might also do this. Yeah, and so this is a bit of a gamed example in the sense that, being such a well-known company, even the generic embedding model is gonna recognize that these two are very similar. So it is gonna give us very high similarity scores for AWS and Amazon Web Services. One point here is that we also get a very high score for these two Amazon Books and Amazon Web Store. And what that tells us here is that, if I can find the two nodes, we don't have a lot of properties for them. Like, all we have is this industry and a name for each. And of course, the fact that there's Amazon in the name and the industry is quite similar. it makes sense that the cosine similarity is going to be quite high. But what this tells us is that, and I'm going to mention this later as well, but one thing I found is that the quality of your extraction really influences the quality of your entity resolution a lot, because the more properties you can extract in the early stage of your graph construction, that just means that you have more to play with when it comes to entity resolution and defining the process for your entity resolution. You'll have different attributes for differentiating different nodes. And whereas if you just have a very limited amount of information, then the nodes are either going to be completely different or completely similar. Like all the companies in one industry, for example, might show up very, very similar in your efforts to do entity resolution, and it can be difficult to actually differentiate them in the way that matters. Now, with the cosine similarity and the node similarity, what we now want to do is we are going to combine them, as I said, into one score in a very simple way in this case. But here again, like you could have, and you probably would have, a lot more, let's say, nuance to how you actually calculate the final score. You could do a mean, you could do a simple multiplication as we've done here, but you could also add weights to one aspect of the scoring, depending on what you think is gonna give you the most signal about the duplication. So that's something that you'd also have the option to think about here, how to do best. But for this demo, we're just gonna do a very simple multiplication, getting us this combined score, which just in a very simple sense combines both the node similarity based on the structure, but then also the cosine similarity. And after that, however you get to that final stage, whatever your process looks like, what the deduplication is typically going to look like after that is simply setting some threshold or some rule for you to decide that two nodes are in fact the same. And here we are going to use this same as relationship that we're going to create between two nodes once we do decide that they are the same. And we're just going to use this unusually low threshold of 0.20, but it's going to work for our purposes here. And then we are going to iterate over all the rows in our data frame, see which node pairs have a similarity score above our threshold, and then we can create the same as relationships. And now we can see that now these two nodes are in fact tagged as being the same. And so with that in place, the last thing we need to do is we just need to merge the nodes that have the same as relationship in this way, finding the node pairs that have the relationship. We're going to delete the same as relationship right after that because we don't need it anymore and we don't need it to be cluttering our graph beyond this step. And then for all those node pairs, we're just going to use the APOC refactor merge nodes, which is going to combine these node pairs and merge the relationships as well. And that's going to be the end of our deduplication process, basically. But here again, although it seems simple here, but in reality, this is another point where you would have to do some consideration because, okay, you have your two nodes that you want to merge, but if they have conflicting properties, for example, they have different emails or whatever else, different properties or different relationships, which ones do you want to prioritize? Because essentially you're going to have to choose one node to keep and one node to delete, and then just how you choose that node, whether you want to use some kind of creation date or updation date and select the newer one or maybe the older one. In reality, that's also a consideration that needs to be made at this step. But now if we run this, then the end result should be indeed that we no longer have Amazon Inc. And then we also don't have AWS here. And that's basically the end of the demonstration. I would say it is, like, as I mentioned, it is sadly almost a bit of still a simplified example, because in reality, these processes would be very, let's say, multifaceted and very, very elaborate. And it's also difficult to come up with a data set that can match that while also being simplified enough to be followable in a demo.
Yeah.
But hopefully that gives you a basic idea of how you might approach this problem.
Cool.
And with that, I just have a few more final remarks here, and then we can use the rest of the time for some Q&A.
Yep.
I think I covered most of these already before, but yeah, as I said, better extraction, better resolution. The more you can extract good data earlier in the pipeline, the better your options are going to be, and better your results are probably going to have in the resolution. Particularly if you can find ways to find these kinds of unique identifiers in the extraction phase, whether it's emails or phone numbers or some stock tickers, stock symbols, something that you can use to anchor entities as being a particular type of entity. That's really going to help your process later on. And yeah, this I said to Tomas at the very beginning. The reality is that it's here we deduplicated companies, but in a real scenario, we would probably also have duplicates of people, duplicates of services, duplicates of brands, and we wouldn't be able to use the same logic, the same properties, the same embedding configuration for one node type that we can use for another. So in reality, you'd probably have to define this kind of a process of steps for as many different duplication problems that are going to happen in your particular graph, and then just find a way to also run those in some particular order, because the order is also going to matter, because every time you merge some nodes, you resolve some entities, it's going to change the structure of your graph. And then if you use that structure to compute similarity for some subsequent steps, then the order of the steps is also going to be important. Final note is that LLMs, I think, also can be one useful tool in this step, as well as the extraction, but also the resolution. Like, it's obviously not feasible to just feed your entire graph to an LLM and ask it to spot duplicates beyond a certain size of a graph. That just obviously isn't feasible. Anytime you want to update some data is to feed the whole graph to an LLM. But if you do use methods like the ones I described here to narrow down the scope of, okay, here we have some potential duplicates in this section of our graph, then maybe a smaller slice you can then pass on to an LLM for also some further, let's say, validation or further analysis to help highlight those deduplicates or those duplicates. So some combination of like that. I haven't worked with that myself, but I think if I was going to make a video continuation on that, I think that would probably be a significant part of it. So, thank you.
Cool. Thank you very much, Johannes. That was cool. That was good to see, good to hear, and thank you for the demo, especially that made it all a little bit more real life, I would say. So that helped a lot. There were a couple of questions in chat. I'd like to talk about. I think they are interesting ones. So Alex asks, any suggestions for metrics that might be used to help identify a threshold? So I think what they mean is when do you think a similarity score is high enough that you would say, okay, this is now good enough to deem a merge? And in your case, it was pretty clear. You look at AWS, you look at Amazon Web Services. This makes sense. But the Whole Foods and Amazon Fresh example was like, okay, yeah, there is some similarity there, but maybe not enough. Do you have some experience on that? Do you have some ideas of how to approach that?
I'm trying to avoid giving the cop-out answer of it depends, but
yeah, but it does, I guess.
the reality is that I think the key factor there is that like our threshold here was set very low, but in a different kind of graph, you might have just a baseline, a lot of similarities between entities as a baseline, a lot of shared structure, shared properties, without that indicating necessarily that they are duplicates. Whereas in another one, even one or two key relationships, like for example, if it's like one of these very high signal relationships, like having a certain CEO or having a certain product, that might be like a dead giveaway that as long as this one relationship is shared, the threshold can be very low. If that makes sense. I think, yeah, it just comes down to how much similarity there is between your entities as a baseline, and then you are looking for the outliers beyond that baseline. But if your baseline is already like very low and there isn't a lot of similarities as a rule, then even small deviations above that baseline might indicate that there is a duplicate there.
Do you think it might help to add vector search on top of the node similarity or the looking at the graph structure and add another tier to it? Is that something that would be helpful?
I mean, in principle, yeah. Like all that cosine, like vector search is basically in most cases is just cosine similarity. So basically, that's already, we aren't doing a search exactly, but we are basically doing the same. The scoring is based on the exact same metric that a vector search would be based on. So in some sense, we are already doing it.
Yeah. Okay. Cool. Thomas, you look like you want to say something.
Yeah,
I'm eager to hear Thomas's.
But because I'm gonna say first of all, it was this week or last week I talked with some people who submitted to arXiv, but they haven't published a paper yet, and they did the exact same thing that you did here, which is just basically take the cosine similarity of names and then try to basically just compare the cosine similarity between entities. And then in their case, they took a really high threshold because they would rather have false negatives than false positives, right? So you rather not merge by mistake than merge by my mistake, if that makes sense, right? So if that means that two entities, if they're different, they will still be different, but two entities that might be the same might not be merged in that case. So like when you're talking about threshold, it also like depends. You wanted to avoid it, but it really depends what you want to do and like what's your preference. Are you more strict or less strict? And what I wanted to say is that with like even with entity deduplication, you don't have to merge the final nodes, right? If you say these two are identical, right, based on threshold, you don't have to merge them. You can just leave the same as a relationship, and then maybe have like a manual review that someone who basically like a domain expert who says, okay, this is and this is not, or it could just stay same as forever in the graph, right? Because when you merge the nodes, you kind of lose some of the information, and then you don't really know how to say, if you made a mistake, you will never know that mistake was made because you merged that information, right? So maybe in some cases it makes sense to not merge the nodes at all.
Yeah, that makes a lot of sense.
That's a good point.
And yeah, I mean, like you said, LLMs, a lot of people are using LLMs, but it can be quite costly.
Yeah.
It can be quite costly, and then it depends. Like if you trust an LLM, or like how much they trust an embedding property, and it's like, yeah, I mean, I don't know, but what you could do is, like, for example, use an embedding Similarity to find like potential candidates, and then the final step, the authorization, is done by an LLM to say, okay, this is to be merged and this is not to be merged. So that could be like more automated and expensive way of doing it.
Yeah. Is a good comment / question from Peter in chat right now. If entities change over time, is there a best practice for representing that in a graph? Do you once you do the merge, once you decide, okay, these have been duplicates, do you want to keep this tracked somehow? Is this something you would put there, or is this something you usually don't?
Yeah, I mean, you could say usually I mean, there are best practices for representing changes over time. Right? So you have some versioning based on time, and then it depends how complex and granular they want to be, because you can have like states of each entity, sort of, right? What's the state of entity in like 2020, and what's the state of that entity in 2021? So there's a lot of things you can do, but like my advice would be just try to keep it as simple as possible. Right. Yeah.
Yeah, I mean that's good, and yeah, like you said, it depends a little bit on what's important and what you want to get out of it in the end. If a full history is very important, then that makes sense to add that. If it's not as relevant, maybe for some reason or other, then maybe keep it simple and cut down a little bit on the overhead. There is another question from Manuel to both of you. What do you think about the idea of applying any of the re-anchor solutions out there to identify high similarity for entity resolution? And he adds, it is true that with low context, nodes and properties sometimes can be very overkill, but I have the impression this could be a good approach for the similarity identification in a first stage. Any idea? Re-anchor solutions. Does that ring any bells?
Yeah, I mean, isn't re-anchor just again some sort of similarity, right? Because I think in RAG applications, when you do re-ranking, it's kind of another, so it's not the same. Like, for example, if you do a RAG application, first you, let's say, do cosine similarity with like text embeddings like ADA 002, and you select like top 100 results, and then you do re-ranking to find the most relevant one. So re-ranking is kind of another similarity metric, right? So yeah, I mean, definitely the more similarity metrics like reasonable and with signal similarity metrics that you can incorporate, the better, right?
Yeah, and also what re-rankers often use is some kind of training data of examples that I think ties into what I said about fine tuning in particular. So you could have some training set or test sets of well, it would be I wouldn't want to define that kind of a test set for this kind of application because it would be a lot of work. But if you were going to re-ranking is just another scoring process. That's all it is. Applying some conditions. Usually it's just a different kind of embedding. Sometimes it involves some user preference data that we have from a history, results in the context of RAG, results that have been preferential to users in the past. We can use that to re-rank results in the future. So sure, you could apply something similar here, but it's not so different in some sense to the kinds of methods we talked about here earlier. It's in some sense it's just a different name for doing more of the same stuff, like Thomas said.
Cool. There's one more question from Himanshu. For real-life pipelines, though, extracting more properties seem to be better, but these other properties also have high amount of duplicates in them. Any idea, suggestions for that?
Yeah, I would generally say more is better, because you can always choose which properties you can select for your similarity computation. And then if you have more to choose from, then you can probably just try and choose the ones that are most, let's say, most signal, most distinctive of each entity. And in other words, if you compare on those, then that's going to be more of a better results for your similarity scoring. Yeah, it can be problematic if you have a lot of properties that are just shared across the board and can bloat your similarity scores. Mm-hmm. But I think that's you can set your thresholds higher. You can not select some of the properties that are just going to be shared between the nodes. So yeah, I would still definitely say more is better, and then you can choose which ones to use.
Okay.
Yeah, I mean, I would just add that basically this is a really hard problem that before LLMs, even academia was interested in, and it's not a solved problem, right? It's just do what you can with the options that you have. and that's it, because there's also one we didn't mention specifically, but there's also the concept of entity linking. So if you have a target database that you can link your entities to, basically, for example, the most common example is having Wikipedia as your target knowledge base, and then you try to map entities in the text to Wikipedia, right? So that is your kind of disambiguation, deduplication part, where you basically for each entity return Wikipedia ID. And for a long time I was a fan of that, but that's not really a flexible solution, right? Because Wikipedia knowledge base is nice, but now let's say we want to extract internal documents of a company. I mean, not all employees are on Wikipedia and stuff like that, so there are always trade-offs. But there's and I think with the entity linking. There are like some end-to-end models that you can take a look at, which is quite interesting. So you kind of train a model to do the disambiguation for you based on like available options. And yeah, like I said, people have tried a lot of things, and it's not a solved problem. So yeah.
Tricky. Maybe
I will also say maybe on a I mean it's everything Thomas said is true. As a note of hope, I would also say that like there is a spectrum of applications here, and it's not just like you always need to get your graph from unstructured data to something that's pristine and consistent and doesn't have duplicates. But often you can lean on like some existing relationship structure in your data. You already have some links that are like known and high quality, and then you can maybe just build on that by adding some extracted unstructured data. And then the problem does become a little more feasible. But yeah, if you are trying to build a graph application from just like entirely LLM extracted data, it's like basically an unsolved problem in a lot of ways.
Yeah, but the good thing is, like you said, that a lot of times we have like a good enough cutoff, and we can say, I mean, it's good enough because even like Google does that. Like I know there are some companies that scrape the internet and kind of do the same thing, and like for the most part, it's fine, right? So like if you can kind of identify what's your like good enough threshold and just try to aim to achieve that, I think it should be fine. I mean, it's gonna take some work, obviously, but it's achievable. Like Johannes said, it's not like you're gonna just waste your time.
Yeah, it's tricky. Maybe we cover one more question before we close. That was sent in from Doron, and they ask, how does this method that you just showed, Johannes, how does that compare with integrity checks in relational database? Are there can you compare it at all? And is there any lessons to learn from using this system or the other system, or is that not really comparable?
Well, I think it's almost more comparable to what Thomas said about having references in your entities to, let's say, Wikipedia article IDs, where you can validate the data from the source level. I think that would be like, that would be maybe the closest equivalent.
Okay.
That comes to mind.
Cool. All right. Yeah, and I think with that, we can close it for today. Thank you very much, Johannes. Thank you very much, Thomas, for joining today, for the demo and for the slides, and for the time, obviously. So that was really nice, and a cool demo and hands-on session. Thank you all for watching this session today. Before you all go, I'd like to remind you that we run a couple of workshops this week, next week, and afterwards, starting with an intro to Neo4j session on Thursday. So we will be conducting these online training series. So if you are interested in joining one of those, more of those, all of them, then check out the link I posted in the chat, or use the one that is visible here on the screen, and suggest you to join one of those if that's an interesting topic. That also means that we'll take a little break with Neo4j Live over the next couple of weeks in favor of this one. So next session is going to be early April, I think, with a Going Meta episode. So until then, we continue doing trainings and all that stuff. So we'd like to see you there, and join us then. Again, thank you very much, Tomasz and Johannes, for your time today and for the presentation. Thank you all for watching, and yeah, I hope to see you soon. Oh yeah, one more question, Johannes. I forgot about this. Is your demo, is this available somewhere? Is there a GitHub repo or some kind of link where people
Not yet.
check it out?
Not yet. I'm gonna share. I'm gonna try and share it later this week.
Yeah. And if people
And
would like to reach out to you,
I can send it to your way.
Yep.
Maybe I'll comment it on the live stream, YouTube
Yep,
recording,
perfect.
something
Then
like
I'll
that.
add it to exactly perfect. Yeah, cool. Once it's available, then we add it to the video description, and then there's also a means of getting in touch with you, Johannes, if need be. I guess.
Yeah.
Yep.
Cheers. Thank you
All right.
both.
Cool. Thank you very much. Take care.
Bye.
Bye.
Ciao.